So if we look at what we've created so far, we've got, whoops, sorry. We've got a bounce and a bounce. Now the problem is the bounce looks more like it's floating. You know, the ball is just kind of gradually coming down. Now remember we talked about that ease in and ease out function that the software naturally has, or by default has built into it. And that's one of the problems we're having right here. The bounce doesn't look like a quick, hard impact. It instead looks like a floating, as if the ball, or it was almost like a balloon full of gases, helium is coming up and down. So we're going to go in and see if we can't modify that to make it look more like a bounce. So we need to make that reaction quicker. So what we learned last time we were here in the graph editor is, nice smooth curves represent very slow, subtle changes. Here, okay, the green is the translation, and you can see it starts as we go across the platform, comes out, and then descends, and then there's a very smooth curve or arc to transition between when it hits the ground and then ascends back up to its peak, and then another nice smooth arc. So what we're going to do is I'm going to grab that point and I'm going to say tangents, break tangents. So the tangents are the two little handles on either side of the keyframe. All right, so I just said break tangents. That means I can take this point and move it independent of the other. Remember we saw this earlier where if I take a tangent, I take a handle, I move it, the other one automatically moves with it. By breaking the tangents, I've now changed that. So what I've done here is essentially said, like we talked about when we first did the translation Z, I've made this descent almost a straight line. So it's really rapid. And then the ascent, or the ascent, is going to be, I'm going to make that go up, but I want it to level off. So what I'm envisioning is the ball gains energy from the impact. It's fighting gravity with that energy. As it gets to the top, it starts to lose that energy, so it slows down. That's why the curve gets smaller. Then it gets to a point where the bounce energy is gone and it's now being pulled by the gravity. Now I can't make that change because I get this, both tangents will move. So again, I have to grab my point, break tangents. Now I can take this side. In other words, after it's hit the peak, I can essentially make it come down really quickly, as if gravity is pulling it back down. And I found I probably want to make that just a little subtler. But you see, I want it faster than this. Now here, at the bottom, here's another impact with the ground. So again, I want to break the tangents, make a nice sharp point, break tangents up here again, have the descent accelerate a little bit more, and then down here, I'll break tangents real quick. Well, actually, I'm going to get rid of that point altogether right now, and I'll show you why in a second. Okay, so now I have, this is the curve. So let's see if we can see a difference. Okay, so if it's only for the first two things. Let's see if I can bring this in so you can see it at the same time. Okay, so before we had a very subtle, now watch the difference as it hits the ground. So you see it's a lot quicker. Its time on the ground is very brief. And it accelerates off of that time. Okay, now it's a ping pong ball or a golf ball or some kind of solid ball, so it's not going to do much more than bounce. And there's probably actually some, if you looked at it very carefully under high-speed film, you could probably see there is some change in its shape. But we're going to basically say, okay, so that's how we get the initial bouncing.